Arc fault circuit interrupters, also known as GFCIs, are designed to protect against fires caused by arcing faults. Ground fault circuit interrupters, known as GFCIs, are designed to protect people from electrical shock. The National Electrical Code, or NEC, specifies where GFCIs and GFCIs are required. Typically, GFCIs are required in bedroom circuits to protect against arcing faults that can occur in damaged cores or faulty appliances. GFCIs are typically required in locations where there is a higher risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. The NEC does not allow GFCIs to be placed on GFCI circuits. Firstly, an GFCI is designed to detect arcing faults, which are unintentional electrical discharges that can cause fires. Secondly, a GFCI is designed to detect ground faults, which are unintentional electrical paths to ground that can cause electrical shock. These are distinct types of electrical faults that require different protection methods. GFCIs and GFCIs work on different principles. An GFCI monitors the electrical current for characteristics of arcing faults, such as erratic current patterns or high-frequency noise. A GFCI monitors the current balance between the hot and neutral conductors. If there is an imbalance, it indicates that current is leaking to ground, and the GFCI will trip to interrupt the circuit. Combining GFCI and GFCI protection can lead to nuisance tripping. If a ground fault occurs, both the GFCI and GFCI may trip, which can be inconvenient and confusing. It is essential to understand the specific requirements of the NEC and any local electrical codes to ensure that electrical installations are safe and compliant. Always consult with a qualified electrician for any electrical work. In summary, GFCIs protect against fires caused by arcing faults, while GFCIs protect against electrical shock. They are designed for different purposes and are typically required in different locations. Therefore, a GFCI outlet should not be placed on an GFCI circuit. The NEC is a comprehensive set of standards for electrical wiring and equipment in the United States. It is updated every 3 years to reflect changes in technology and best practices. Electrical inspectors use the NEC to ensure that electrical installations are safe and compliant with the code. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. It is essential for electricians and other electrical professionals to be familiar with the NEC to ensure that they are performing their work safely and correctly. The NEC is not a law, but it is often adopted by state and local jurisdictions as the basis for their electrical codes. This means that compliance with the NEC is legally required in many areas. The NEC is developed by the National Fire Protection Association, or NFPA, a non-profit organization that develops codes and standards for fire and life safety. The NFPA brings together experts from various fields to develop the NEC, including electricians, engineers, manufacturers, and regulators. The NEC is a consensus-based standard, which means that it reflects the collective judgment of the experts who participate in its development. The NEC is organized into chapters, articles, and sections. Each chapter covers a broad topic, such as wiring methods or equipment. Each article covers the specific aspect of that topic, such as branch circuits or overcurrent protection. Each section provides detailed requirements for that aspect. The NEC also includes tables and figures that provide additional information and guidance. These tables and figures can be very helpful for understanding and applying the code. When using the NEC, it is important to refer to the latest edition. The NEC is updated every 3 years, and each edition contains significant changes. Using an outdated edition of the NEC can lead to unsafe or non-compliant electrical installations. The NEC is a complex document, and it can be challenging to understand and apply. It is essential to have a thorough understanding of electrical principles and practices to use the NEC effectively. Many resources are available to help electricians and other electrical professionals learn about the NEC, including training courses, books, and online resources. It is also important to stay up to date on changes to the NEC by attending continuing education courses and subscribing to industry publications. In addition to the NEC, many other codes and standards may apply to electrical installations. These include state and local electrical codes, as well as standards developed by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI. It is important to be aware of all applicable codes and standards when performing electrical work. Always consult with a qualified electrician for any electrical work. They can help ensure that your electrical installations are safe, compliant with the code, and that GFCI and GFCI protection is properly implemented.